This is a tutorial on Capsim in which we're going to design a digital communication system that incorporates both concepts in signal processing and also communication. It's going to be a simple digital communication link where concepts of block creation, connection, changing parameters, plotting, probes, and creating hierarchical blocks will all be demonstrated. And we're going to start right now by actually creating a blank universe or topology. And what we're going to do is the first block we're going to place on here is what you call the binary data generator. And to do this, it's convenient to just park the block list over here, pick the block, hit OK, and point exactly where you want the block placed, and the block will be placed at that point. This particular block generates random binary data and has many simple parameters. One of the parameters is actually the total number of bits to generate, which we're going to set to 1000 bits. There's also an initializer for a shift register and other parameters related to what we'll talk about later, which is pacing. The next block we're interested in is a simple coder. The coder will input bits and map them into symbols. In this case, plus and minus 1 would be fine. And it's called the line coder. So let's go down the list here and find that particular block. Here it is, line code. Select it, move it, and place it. And of course this icon shows up. If we had an icon for it, it would show up like this. Otherwise, a block would be generated with a name. The coder block basically accepts bits and maps them to symbols. Let's take a look at its parameters. The parameters are the coding type, which we're going to select by default as binary. You also have biphase, 2B1Q as in like DSL, and other coding techniques. And the samples per baud, which is an important parameter. In this case, the default is 8, and we'll leave it as a default. What this means is that for every bit, it'll actually generate coded symbol, and the coded symbol would oversample by a factor of 8. That is, it will generate an impulse with the symbol and with 7 zeros following it. And that's exactly what we want to do with digital communication link. Each symbol as an impulse would then feed what you call a pulse shaper and act as an impulse response. The pulse shaper's impulse response is actually the symbol. And of course, it's the sum of all those symbols for every symbol generated per bit or a combination of bits that will constitute the baseband digital communication link's actual waveform. First thing we want to do is connect the block to the coder, the data generation block to the coder block. So we click on the block and say connect an output and just select the coder, and it is connected. There's another way, of course, to make these connections a little bit faster. We'll talk about those later when we discuss some of the options. The next block we want to consider is actually a pulse shaping filter. In this case, we're going to use Nyquist pulse shaping. And since we're talking about, we will be talking about both a transmitter and a receiver, we're going to select the square root Nyquist filter. So as we go down the list here, you're going to see the square root Nyquist filter block right over here. I'm going to select it, and we're going to place it. What I can do is also move a block if I wanted to place it closer, for example. This is a pulse shaping block. It actually does a Nyquist pulse shaping. It has a parameter to control that, the amount of excess bandwidth, so to speak. And it's a square root one because we're going to split this between transmitter and receiver. First thing we want to do is take the coded symbols and connect them to the pulse shaping filter. What we're going to do is put another pulse shaping filter, another square root Nyquist pulse shaping filter right over here. Actually, let's move this guy down a little bit. And we're going to actually connect these two to each other. The deal being that between the two Nyquist pulse shaping filters, we get a full Nyquist filter, and we're going to look at its eye diagram. For now, let's connect these two guys together. Very simple. And let's also connect a eye diagram. So let's select, one way to select a block is to just type its name in, or you can go through the list. In this case, we're looking for the eye diagram. So we can just type its name in and place it on the topology. Now, typically an eye is also a probe. So all we have to do now is just connect the pulse shape to the eye, and we're ready to run a simulation. To run a simulation, you just press this arrow here, the arrow symbol here, which is run, and you can actually run the simulation. You can also use the menu. Before you do that though, it's always, before you run anything, it's always a good idea to save the topology. So we go to File and say Save As. In this case, we're going to call this Tutorial 1. And now we've saved it. Always a good idea to save before you run. And Capsim is based on simulating C blocks. A lot of these C blocks are generated by the users, and depending on how people connect them and how many what the parameters are, it's always a safe bet to save before you run. So let's run the simulation, and you get an eye diagram. This is a very open eye. You can see that all the pulse shaping and Nyquist pulse shaping is working. This is of course for a system in which we have 100% excess bandwidth, and that can be changed by using the parameters to the pulse shaping stars. At this point, we'll take a break and come back to the tutorial.